Hello everyone, welcome back to my YouTube channel. So this is part 4 of our topic, that is sets. In previous part, we have discussed about subset, universal set, complement of a set, and how to draw a Venn diagram. So let us proceed with today's session. Today we are going to learn about operations on sets. So which kind of operations we perform on sets? Like in numbers, we had addition, subtraction, multiplication, division. Similarly, there are some operation on sets. So let us discuss it. In earlier classes, we have learned how to perform operation like addition, subtraction, multiplication, and division on numbers. Each one of these operation was performed on a pair of numbers to get another number, right? For example, when we perform the operation of addition on pair of numbers 5 and 13. So in order to perform the operations, you need at least two numbers, at least a pair of numbers. So 5 and 13. So we get number 18 if you add it. Again, performing operation of multiplication on the pair of numbers 5 and 13, we get 65. So to perform any operation on numbers, you require two numbers, at least two numbers, minimum two numbers. So similarly, these are some operation which when performed on two sets give rise to another set. So for performing any operation on sets, we require minimum two sets. Like we require two numbers to perform operation on number. Similarly, for performing operation on sets, we required two sets. Now let us discuss which are the operations on sets. So first operation is the union of sets. So what do you mean by union? So first, let us consider two sets, like let A and B be any two sets. The union of A and B is a set which consists of all the elements of A and all the elements of B. It's like you're adding the two sets. Okay, union of two sets means it's like adding you're adding a two sets. Like you're consider two sets A and B. So whatever result we'll get, the result set will be it will be consisting of all the elements present in A and also all the elements present in B. The common elements being taken only once. If there is certain common elements in both set A and set B, we'll take that elements only once. Okay, we need to write on the distinct elements. The symbol U, it's like U, is used to denote the union. Symbolically, we write A union B. Okay, let us see some example. Now here we have a set A. Set A is equal to 2, 4, 6, 8. And set B is equal to 6, 8, 10, 12. Now if I want to find A union B, now what do you mean by union? It is a different set. Set A is different, set B is different. But I want union of both the sets. Means a different set will be formed, which will be having all the elements from A and all the elements from B. Now here you can see A union B. So I will take all the elements from A. So 2, 4, 6, 8. I have took all the four elements from A. And I have to take all the four elements from B as well. But you can see that the element 6 and element 8, these both elements are similar. They are present in A as well as B. So we will write that both the elements only once. Okay, we will not write it twice. We want only distinct elements. So the next two elements, that is 10 and 12, they are only present in B. So we'll write that 10 and 12. So this will be my new set. My set A and set B are different sets. And if I take the union of both these sets, I will get a new set. And that in that set, I will get both the elements from set A as well as set B. Okay. So A union B. So my elements are 2, 4, 6, 8, 10, and 12. So I hope you understood what is the concept of union of sets. The union of two sets A and B is the set C. So it is a different set which consists of all those elements which are either in A or in B, including those which are in both. In symbols, we write A union B is equal to set of all X such that X belongs to A or X belongs to B. So this is the definition of union of sets in set builder form. The union of two sets can be represented by a Venn diagram as shown. So how do we represent the union of two sets in a Venn diagram? So this is our Venn diagram. So this is a universal set. This is set A and this is set B. Okay. If you want a union of two sets, union of sets means in that sets, both elements of set A and set B are present. So also the elements of set A is present and also the elements of set B is present. So we will just shade the set A and set B. So here you can see we have shaded set A and set B respectively, since union of two sets include both the elements from set A and set B. Let us discuss some properties of union of sets. First property is A union B is equal to B union A. So you can write anyhow. If you write A union B, that will also give you same answer. B union A, that will also give you same answer. A union phi is equal to A. What is this phi? Phi means empty set. So your set A has two elements, 1 and 2. And there is another set, set B, which is a null set. So if I take the union of both the sets, you are going to get the same set A in which there are elements. The another set is there you don't have any element. So this is known as law of identity. So A union null set or empty set will yield you the original set only. A union A is equal to A. So if you make union of the set itself, you are going to get the same set again. Universal set union A is equal to universal set. Now, so for example, my universal set is 1, 2, 3, 4, 5, 6. These are my 6 elements in universal set, and my set A is 2, 4, 6. Okay, so this is my universal set and this is my set A. Now, if you want to write the A union of both the sets, so universal set union set A. What do you mean by union? Union means a particular set in which elements from both the set will be present. So I will include all the elements from U and all the elements from A. So I will include first elements from U, 1, 2, 3, 4, 5, and 6. If you see my elements in set A, 2, 4, 6, all these three elements lies in the universal set only. So I am going to write it once only, as I want distinct elements. So if I see the universal set union A, the new set which I have formed, it is similar to universal set. So U union A is nothing but U only. Then A union A complement. A union A complement is equal to universal set. How? For example, my universal set is 1, 2, 3, 4. This is my universal set. Then my set A is 1 and 4. So what will be my A complement? A complement means such elements which are not present in A but present in universal set. So 1 is present in A, 2 is not present in A, 3 is not present in A. So my A complement becomes 2, 3. If I take union of these two sets, union of A and A complement. So what I'm going to get? A union A complement is equal to 1, 4, 2, 3. All the 4 elements are different. And if you observe, all these 4 elements are present in universal set. So I can write A union A complement is nothing but universal set. If A is a subset of B, then A union B is equal to B. Let us see this with example. A is a subset of B. So my set B consists of elements, for example, 1, 2, 3, 4, 5. So these are my 5 elements in set B. And my set A is 2, 4. Now I can say that A is a subset of B because all elements in A are present in B. Both the elements in A is present in B, so I can say A is a subset of B. Then, if this is a condition, if A is a subset of B, then A union B is equal to B. So if you take A union B here, so what you will get? All the elements present in A and B. So 1, 2, 3, 4, 5. These are elements present in B. And if you observe 2 and 4 are already present in B, so we are not going to repeat it again. So this will be my A union B. And if you observe, this A union B is nothing but the set A union B and set B both are same. So if A is a subset of B, then A union B is equal to B. Similarly, if I write B is a subset of A, if B is a subset of A, then A union B will become A. Understood? So the set which is subset of another set, that set will be your answer. B is a subset of A, then A union B is A. A is a subset of B, then A union B is B. A is a subset of A union B, and B is a subset of A union B. If you take two sets, set A is 1, 2. Set B is 3, 5. So these are my two sets. What will be A union B? A union B will be 1, 2, 3, 5. This will be my A union B. Now, A is a subset of A union B. Means all elements present in A is present in A union B. So every element, these are two elements, 1 and 2, they are present in A union B. Yes. So this is right. B is a subset of A union B. Means every element in B must be present in A union B. So my two elements 3 and 5, they are present in A union B also. So B is also a subset of A union B. So these were some properties of union of sets. Now let us move to the next topic, that is intersection of sets. Now this is another operation. First was union and second one is intersection. What is intersection? The intersection of sets A and B is a set of all elements which are common to both A and B. Intersection means something it's common. So I am taking set A, set B. The elements which are common in both the set, that will be my intersection of set. That will be a new set which is intersection of set. So for union we use this symbol, and for intersection we use just opposite like this symbol. So this symbol is used to denote the intersection. The intersection of two sets A and B is a set of all those elements which belong to both A and B. Symbolically, we can write A intersection B is equal to set of all X such that X belongs to A and X belongs to B. In union, we wrote here OR, and in intersection, we wrote here AND. AND means those elements which are in A also in B. And in union means all the elements which are in A and all the elements which are in B, and the common elements will take once. In intersection, we are going to take only the common elements. The rest of the elements we are not going to take. Let us see some examples. Consider the two sets A and B. So my set A is 2, 4, 6, 8, and set B is 6, 8, 10, 12. Now, if you observe both the sets, we see that 6 and 8 are the only elements which are common to both A and B, right? In set A, we have 6, 8, and also in set B, we have 6 and 8. So these are the only two elements which are common in both. So hence our A intersection B becomes 6, 8. Now definition of intersection of sets. The intersection of two sets A and B is a set of all those elements which belong to both A and B. Symbolically, we write A intersection B is set of all X such that X belongs to A and X belongs to B. The intersection of two sets can be represented by a Venn diagram as shown. Here is a Venn diagram, and if you want to show A intersection B, intersection means a common part. So this will be my common part, which is shared by both set A and set B. So I hope you understood the difference between union set and intersection of set. Let us see now the next subtopic, that is disjoint set. If A and B are two sets such that A intersection B is equal to 5, then A and B are called disjoint sets. A intersection B is 5 means set A and in set B, there are no common elements. So A intersection B is our null set. For example, let A is equal to 2, 4, 6, 8 and B is equal to 1, 3, 5, 7. So here you can see, here there are 4 elements, here also there are 4 elements. But none of the element is common. None of the element is same. Then A and B are called the disjoint sets. If A intersection B is 5, then that two sets are known as disjoint sets. Because there are no elements which are common to A and B, the disjoint sets can be represented by means of Venn diagram as shown. So this is a Venn diagram for disjoint sets. So set A is separate, set B is separate. There is nothing common in set A and set B. So I hope you understood what are disjoint sets. Now let us learn some properties of intersection of sets. A intersection B is equal to B intersection A. So this property is applicable for union of sets also and intersection of set also. Anyhow, you can write A intersection B or B intersection of A. Both the answers will be same. Phi intersection A is equal to phi. Null set intersection some set. It is going to be phi because there is nothing common. In null set, you don't have any element. So there is no element common. So your new element is going to be the same, that is an empty set. Universal set intersection set A is equal to set A. Okay, now let us see one example. So my universal set is 1, 2, 3, 4. This is my universal set and my set A is 2, 3. So universal set intersection A. Intersection means we have to find the common elements. So here you can see 2 and 3. These are the only two elements which are common. So my answer becomes 2, 3. And if you observe, this is similar to set A. So universal set intersection A is nothing but set A. If you remember in properties of union of sets, we discussed universal set union set A. It will give you universal set. And intersection, you will get the set A. Okay. Next, A intersection A is A. Similarly, A union A is A. Same thing, A intersection A is A. A intersection A complement is equal to null set. In union of two sets, we have seen that A union A complement is universal set. Because we have to include all the elements in as well as in A and A complement. Here we have intersection. Now in A and A complement, there are no common elements present. A complement is what? Such elements which are not present in A. So there will be no common elements present in A and A complement. So we are going to get a empty set here. If A is a subset of B, then A intersection B is equal to A. Let us take the same example here. A is a subset of B. Let us see, this is a set B. B is equal to 1, 2, 3, 4 and A is equal to 2, 3. So from this we can write A is a subset of B because every element in A is present in B. Then A intersection B. So A intersection B, what is A intersection B? 2, 3. It is nothing but equal to set A. A intersection B. Okay. Common elements. Common elements from A and B are 2, 3 and also the set A is itself 2, 3. So if A is a subset of B, then A intersection B is equal to A. If I'm writing B is a subset of A, then A intersection B is equal to B. Next, if A intersection B is equal to B, then B is a subset of A. Same thing I told you before. This is just inverse of it. A intersection B is subset of A and A intersection B is subset of B. So here only I will show you with the same example. So these are our sets. Okay. So this is set B and this is set A. Now A intersection B. What is A intersection B here? 2, 3. Now A intersection B is a subset of A. Is it a subset of A? Yes. Every element of A intersection B is present in A? Yes. So this is correct. Next, A intersection B is also a subset of B? Yes, because each element from A intersection B is present in B. So this is also correct. Let us move to the next topic, that is number of elements in a set. Now, how do we find number of elements in a set? Now, for example, let A is equal to 3, 6, 9, 12, 15 is a given set with 5 elements. So number of elements in a set A is denoted as n of A. How we read it as n of A. That is number of elements in set A. Thus, n of A is equal to 5 because there are 5 elements present. 1, 2, 3, 4 and 5. Let B is equal to, these are the elements. How many elements are present? 1, 2, 3, 4, 5, 6. So 6 elements. So n of B becomes 6. Now here we have one exercise. Number of elements in union and intersection of sets. Now in the previous example, we have discussed a number of elements in a single set. This is a separate example. This is a separate example. Now if I have to take union and intersection, how I can determine the number of elements in that set? So let us consider two sets, set A and set B, as given above. Above means the same set we are considering, these sets, set A and set B. These two sets we are considering n of A plus n of B, n of A plus n of B. So we have seen that in set A we have 5 elements, so n of A is 5, and in set B we have 6 elements. So we can write 5 plus 6, that is equal to 11. So what is A union B? A union B means we will include all the elements. So 3, 6, 9, 12, 15. 6 is already in set A. Then 12 is already in set A. 18, 24, 30, 36. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 elements are there. So we have wrote all the elements A union B. Therefore, n of A union B, number of elements present in A union B, is equal to 9. Now we are going to find A intersection B. A intersection B means common elements. So in this example, here you can see there are two common elements, 6 and 12. So these are the two elements which are common in both set A and set B. So A intersection B will be 6, 12, and number of elements in A intersection B is 2. So my first equation was n of A plus n of B, that is 11. Second equation, A union B, that is 9. And third equation, intersection, that is 2. So these are my three equations. In n of A and n of B, elements in A intersection B are counted twice. Right? Why twice? See, in n of A, we have counted 6 and 12, and we have wrote here 5. In n of B also, we have counted these same elements, 6 and 12, and we have counted it 6 elements. There are total 6 elements. So, while counting n of A and n plus n of B, we have counted 6 and 12 two times. One in set A and one in set B. So, we can write n of A plus n of B minus n of A intersection B. Why minus? Because we have counted that two elements two times. That's why we need to subtract it once. So you'll get 5 plus 6 minus 2 is equal to 9. And what is 9? 9 is equal to n of A union B. And n of A union B is equal to 9. So from these three equations, we can write n of A union B is equal to n of A plus n of B minus n of A intersection B. So this is a kind of formula, you can say. Verify the above rule for the given Venn diagram. So this is a Venn diagram. N of A. So how many elements are present in A? 9, 3, 15, 6 and 12. 6 and 12 also present in A because they are included in set A also. So how many elements are there? 5 elements. So n of A becomes 5. Similarly, n of B, 18, 24, 36, 30, 6 and 12. Again, 6 and 12 are present in B. So we are getting 6 elements in n of B. So n of B is equal to 6. Now you want A union B. A union B means all the elements present in A or present in B. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 elements present. And A intersection B means the common elements in both A and B. So there are 6 and 12. These two are the common elements. So n of A intersection B is 2. So we can see n of A union B, that is 9, is equal to n of A, that is 5, plus n of B, that is 6, minus 2. So 5 plus 6 is 11, minus 2 is 9. So hence we can verify It is verified that the rule is correct. Okay, so I hope you understood how we find a union of two sets, intersection of two sets, what are disjoint sets, and properties of union and intersection of sets. And the last topic, that is number of elements in union and intersection of sets.